Hello everyone, welcome back to the channel. In this video, we are going to discuss about important data structures, that is stack and queues. So these two are important data structures which can be implemented using the interfaces and classes provided by the collection framework. Okay, so we will see what these data structures are and how these can be implemented using the collection framework. So coming to stack, it is a type of last in first out or first in last out data structure, which means that the last element that is inserted in the stack is removed first, and the first element which is inserted in the stack gets removed last. Okay, so it means that if you insert an element first time in the stack, then only after all the elements are removed from the stack, then you can remove that first element that you have inserted in the stack, right? So operations in the stack can be performed from only one side, and that side is generally known as the top of the stack. Okay, and the implementation for the stack is earlier it has a stack class in the collection framework, but it is not recommended. It is a legacy class and not recommended officially. So what to use instead is the deck interface and its implementing classes. You can say it DQ or deck, whatever you feel like. I like to call it deck interface. So yeah, the deck interface and its implementing classes known as array deck is the most recommended way for the implementation of the stack. Now coming to queue, it is a first in first out or last in last out the type of data structure, which means that first element inserted will be removed first and last element inserted will be removed last. Okay, and here also the operation can be performed on one side, but not actually on the one side. Basically it has two sides, one is front side and one is rear side. So from the rear side you insert the element, and from the front side you remove the element. So going by this concept, any operation can be performed only on the one side only, right? And for implementation of queue, you have the queue interface provided by the collection framework. So if you want to see the structure of the stack and queue, it looks something like this. So you can only perform the operation from the top of the stack. You can see here is a top, right here. Okay, and here from the rear of the stack you can in case of queue, you can insert the element at the rear and remove from the front. So this is a typical representation of the stack and queue like this, right? So now we will see how we can use the deck interface to implement the stack. So if we go deck, let's go with this, and stack equal to new array deck. Array deck is one of the implementing classes we can use. So there are multiple methods in the deck interface. So for the stack, the methods are push, poll and peek. Only three methods are there for the stack, and three methods are for queue. We'll see that soon. So we have push. Suppose we push 1, then we have stack.got push 3, then we push 9, and then we push 24. Okay, so we have pushed the 4 elements into the stack, and now if you print the stack, you will see that the order of elements represents it. So here if you see, the order of the elements here is 24, 9, 3 and 1. Okay, so the first element of the stack is 24, second is 9, and then is 3 and 1. So you can only proceed from top of the stack. Basically you can consider the array deck to be an array implementation of the stack. Okay, so you can only insert the elements at the front of the array, or you can say at the index 0 of the array. Now you have another method which is stack.peek. So peek method gives you the element at the top of the stack. So here the top of the stack is 24, so the peek will give you the 24. So if we run the program, we get 24, right? And another method is stack.poll. So what does poll does it prints it gives you the top element of the stack and removes it also. So if you want to remove the top element of the stack, use poll method. And if you just want to know about what is present at the top, you can use the peek method. So these are the three methods which is recommended to use when implementing the stack data structure. There are multiple methods, you can use them. Some of them are similar to each other with some differences, like so some of these methods don't throw exceptions, and some of the methods throw exception with respect to the null. Okay, so if there is a null, like in the case of poll, if you see the first element of this deck is printed or null if the deck is empty. So this poll method will give you null if the stack is empty. But if you use a equivalent method known as the pop method, okay, so it will throw an exception. So it depends on the use case what you want, but these are the three common methods for the stack. Now coming to the queue, we have a queue interface here. So now queue interface is implemented by two classes. One is linked list classes that we have already seen in the list interface video, and another is ArrayDeck. For queue, it's most recommended to use ArrayDeck. Okay, so because it's a bit fast and it's a dynamic array, so for most purposes ArrayDeck is most suitable. Now the method that is recommended to use for the queues are offer, peek, and poll. So we have offer, so we offer 2, we offer 3, and we offer we add. Basically offer means to add into the queue or to insert into the queue. 56, let's do it, and offer 21. Okay, now if you print the queue, the order will remain the same, 2, 3, 56 and 21, because that's how it works, right? 2, 3, 56, 21, because first the rear element is present, first the rear index is present here, this rear pointer is present at the index 0, and when the element is inserted at the index 0, then the rear pointer shifts to index 1. Then again when we insert element here, it shifts to index 2, and like that. So we always insert at the rear of the queue, and from the front we can delete the element. So we have the similar functionality like peek, and similar to peek we have poll. Okay, so if you run this, you see the first element was inserted was 2, so the first element present in the queue, the peek gives you is 2, and poll removes the first element of the queue, so the first element inserted in the queue was 2, so it got removed. So these are the methods of the queue. Now there is another queue or another type of queue which is present to implement for the implementation and is very useful in some situations. It is known as the priority queue. So priority queue basically is a type of queue which puts the element, when you insert the element, it arranges them in the you can say in a order of the priority of the elements. So the default priority of the elements is the ascending order or their natural order. In case of characters or strings, it will be alphabetical order, right? But in the case of integers, those will be ascending order or descending order, depends on it. By default it is ascending, you can change it to descending also, right? So let's define the priority queue also, and let's see that also. So priority queue equal to new. So priority queue is a class. Okay, it also has the same method as queue. So if I insert pq offer 23 pq, or let's change this to So 2, let's change this to 45. PQ.offer 32. Okay, so I have inserted 4 elements into the queue. Let's see in which order does it work. Okay, so I print PQ. Now, as I have said, it will put the elements in the ascending order, but you may not get this order printed as such. What I mean by this is, let me run the program first. So now when I print the priority queue, you can see that the ascending order is not printed here. So the reason behind it is priority queue basically implements a heap data structure, is based on the heap data structure, right? And heap data structure is not a linear data structure like array or list. It is like the trees, okay, in a hierarchical way. So it prints the tree in a particular order, right? Therefore this order is maintained, this ascending order is not there. But to confirm whether this ascending order is maintained or not, what you can do is, first you can call peak. So peak will give you the least element in the queue. So if you run this, you'll get 2. 2 is the smallest element present here. So since, as I told you, it arranges the element in the ascending order. So first you get 2. Now suppose I apply poll. Let's apply poll 3 times. Okay, pq.poll. Okay, so I have called this poll method 3 times. Let me comment out this. I have called poll 3 times. So the first element to remove from this must be 2, second must be 21, and third must be 32, which will validate our concept of priority queue, that it arranges the element in the ascending order based on their priority. So you can see 2, 21, 32, right? Now if you want to change it to the descending order, just you have to pass comparator dot reverse order. So if you do this, now in the poll, the first will be 45, second will be 32, and then will be 21, right? So let's check out. So 45, 32, 21. So don't go by this representation. It may be misleading sometimes, but trust me, the priority queue arranges the element based on the priority. Now the default priority is ascending order. You can change it to descending order, but if you want to customize it also based on some other logic, you can do it using the comparator logic, which we will be discussing in the upcoming videos. Okay, so these were the 3 data structures we discussed: stack, queue, and priority queue. I hope you have understood the basic concept of it, and you may be able to now practice some problems and use them in solving some of the problems. So that's all for this video. If you new to the channel, please subscribe to the channel, and if you like the content, please press the like button and share it with other like-minded people. So that's all for this video. I will see you in the next one. Till then, bye bye.